Here are the answers to Chapter 4's practice quiz. So in Chapter 4, this practice quiz has a little bit more calculation, so you should be quick and know what's going on and try to sometimes answer this more rapidly without having to go through the whole process too long. So here we have a question with a table, and it says refer to this table and talk about the elasticity of demand. If I look at the table, it's very similar to the one that was shown in the notes, that it is very linear. For every drop of $2, there's a 2 units more quantity demanded, and so on and so forth. So extremely similar to the linear example that we had in class, a linear demand curve. And that linear demand curve that we had, that was as such, had a situation where we said that the elasticity along this linear demand curve is not the same all the way through. And if you went through the slides and you figured it out, you could see that at somewhere in the middle, we had an elasticity level that is equal to 1 unit of elasticity, and above it we had, and below it we had different components. So one of the two was below 1, which meant inelastic, and the other one was above 1, which meant elastic. So you could actually go to one of the two ends and calculate it out and figure it out. But the other way to do it is always to put things into perspective. So if I were to go from this point here to this point over here, what I can notice is that I've dropped the price by, let's say, throughout this whole thing by, I don't know, 15% roughly, and I've doubled my output. And I know that to calculate price elasticity demand is my percentage change in quantity over my percentage change in price. So in this, so that triangle is change is percentage change in price. So here I have a very small percentage change in price relative to the percentage change in quantity. So this would be larger what's at the top than at the bottom. So here I would have elastic, which would be, I'll just put a number there, like it doesn't have to be 3, but it would be a number above 1. And over here, if I do the same exercise, well, here I'm dropping the price by half and I only get like a 10% increase in the quantity sold. So here I'd have a very small change in quantity demanded for a very large change in price. So this number would be below 0, below 1, I mean. So it could be, let's say, 0.3. These are just arbitrary numbers. So if I think about this, and it's always going to be the case, regardless of the numbers that we have here, we're always going to have greater elasticities at higher prices, because at higher prices, if the product is really priced high, no one's buying it. And as soon as you drop it a bit, there's massive increases in product being purchased. But if beer is already selling, or another product is already selling at $1 at the bar, if you drop it to 50 cents, it's not really going to increase sales that much because the price was already really low. Inelastic, elastic. So the elasticity is greater at higher prices than at lower prices would be the answer here. If we look at the other options, constant at all points on the demand curve is not true. We could clearly see that it's not the case, and if you calculate it out, you'll see it's not the case. Greater at lower prices is not true. It's the opposite. Elastic at all points, that's false as well, and elastic at all points is also false. If you're not convinced, look at the videos or calculate it out the way that was done with those exact numbers that we have. Okay. So next up here, suppose you're advising the government on changes in the gasoline market. The current price is $1 per liter and the quantity demanded is 2.5 million liters per day. Short run price elasticity demand is constant at 0.3. And if the supply of gasoline is reduced so the price rises to 1.50 per liter, then quantity demanded is predicted to fall in the short run by how much? So if I think about this, if I look at this through, what information did I have? Well, I have the n, so I already know that we have 0.3 here. And if I think about my percentage change in quantity demanded, we don't know. This is my unknown. But if I look at my percentage change in price, well, the new price is $1.50, the old price is $1, and the average price would be $1.25. So I have this piece of information. If I were to calculate it out, 150 minus $1 is 50 cents divided by 1.25. I would get 0.4. So here I have 0.4. If I multiply, because if I have the division here and I want to bring it to the other side, I need to multiply instead of divide. So 0.3 times 0.4, I'd actually get 0.12. So it tells me that my percentage change in quantity demanded needs to be 12%. 0.12 is 12%. If it asked me to know what the new quantity demanded would have to be, well, then you would use that 2.5 that you have, which is the old quantity demanded, and you'd have to kind of isolate it. It would be an extra step. It'd be longer. But here I know that there needs to be a 12% change in quantity demanded. Does this 12% go up or down? Well, actually, if you think about it, as prices go up, it needs to be a drop in quantity demanded by 12%. That's just based on the law of demand. So out of all these answers, as soon as you know it's 12%, you know that this is the right answer here. But what's going to happen to expenditure? Well, the thing that we've talked about in this class is that when we're in an inelastic component, when you increase the price, so here we're in an inelastic component because we have 0.3, which is below 1. So this tells me it's inelastic. Well, because it's inelastic, as you increase the price, you'll have this situation where people will demand less of your product, but not as much as the percentage change in price. Therefore, your revenues are going to go up. And from the consumer standpoint, expenditures will rise. So this explains the two parts to this answer. Suppose national income is rising steadily at 2% per year over a 5-year period. Over the same period, suppose quantity demanded for iPods and iPhones increase at 5% per year, but no other relevant variables are changing. We could conclude that the income elasticity for these products is blah, 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 and that these products are da, da, da. So here, as always, we're talking this time about income elasticity demand. And because we're talking about income elasticity demand, we have this situation where if you think about the equation, it's always going to be a percentage change in quantity over something else. Q is always going to be on top in all 4 equations that we have. So we have this quantity that needs to be on top. So here we're talking about quantity demanded 5%, and that there's a 2% change. So 5 over this 2%, so 0.05 over 0.02. We would notice that we have 2.5. And from the previous video from chapter 3, we said that normal goods could be divided into 2 different types of goods, either necessities or luxury goods. Well, necessities would be any income elasticity demand between 0 and 1, and luxury goods, anything above 1. So this would be a luxury good. Suppose the cross-price elasticity demand for 2 goods, domestic cheese and imported cheese, is positive. Okay, so cross-price elasticity demand is percentage change in quantity demanded for one good over percentage change in price of another good. If they're both moving in the same direction, it means that as the price of, let's say, Pepsi goes up, I now demand more Coca-Cola. This is a situation where we're dealing with substitutes. Because as the price of Pepsi goes up, you demand less Pepsi and you demand more Coca-Cola, so they're moving in opposite directions. So if the price of imported cheese falls, without even looking at the answers, I know that if the price of imported cheese falls, I'll demand more imported cheese based on the law of demand. And because these goods are seen as substitutes, or as that my quantity of domestic cheese moves in the same direction as the price of imported cheese, I know that my quantity of domestic cheese will fall. So there's going to be a fall for domestic cheese and rise for imported cheese. This one here is an example of how you could sometimes calculate things through rapidly without going through this lengthy process of trying to calculate it out. Suppose that the quantity of a good demanded rises from 90 to 110 units. So why I say it's simple is that the average of these two numbers, which you need to do to calculate the percentage change in quantity demanded, is going to be 100. So I know that this is 20 over 100. When the price falls from 20 over 100 is 20%. When the price falls from $1.20 to 80 cents, so this is a situation where $1.20 and 80 cents, the average here is $1. So this change of 40 cents is over $1, so it's 40%. So here I have 20%, which is my numerator because it's quantity, over 40%. So this will give me an answer of 0.5. So that's a quick way of doing it without actually having to calculate it through. You might have to write things down if it's not clear in your head or you want to calculate it with a calculator. But sometimes it's easy or it's good to see ways to fast track an answer. So here were the explanations for chapter 4. Hopefully that clarifies it.